Keyword.
You guys want a Carhartt pen? There might be some extras.
I'm neurotic about my pen. I always have one in my pocket.
Yeah.
Do you know my?
It's a special pen.
It's not a special pen. It's just a uniball pen.
It is a special pen, though. You can't use any other
Special
pen.
to me.
Good check. You should pencil was right.
I saw my wife and I are in the car and we're listening to something and they were talking about it's the easiest way to prevent the common cold is to have their own pen in your pocket.
Oh.
Because the community pens are like just cesspools, right?
Yes.
And so like everyone's like, sign this, and I'm like, no, I'm okay. And I signed my pen. And my wife was like, great, feeding in neuroses. I'm like, it's not a neuroses if it's actually true.
You go to the liquor store on the wrong side of town, you really want to touch that
Yeah,
pen?
really, right?
I don't even want to enter my digits in the damn pad.
Yeah. So you have them.
All right, I guess we're gonna get started, right?
Yeah.
Okay. My name is Brock, and that's Dan, and we're here with Commercial Chemtec. We're a water treatment company out of Seattle. We do work all the way down to Portland, though. Seth invited us here to kind of give an overview of water treatment, why it's important, kind of what we do, and help clarify anything that you guys might have question-wise or other. So anyway. So a few key concepts of good water treatment program: minimizes equipment downtime, minimizes maintenance work. It substantially reduces operating costs with a good program. Some essential things to understand: knowledge of basic water treatment and control equipment. That's hopefully what we're going to provide for you today. And the ability to identify the adequacy of water treatment programs. So hopefully after today, you guys will be able to do those simple things and help you out. My first question is, do any of you have current water treatment problems or have had? Like say towers that don't work because of treatment problems.
Yeah.
What are those?
I've had several. I used to do a lot of startups on a climate-cooled chiller. It's got a brazed plate heat exchanger.
Mm-hmm.
It has a 60 mesh strainer, and they're really stringent on their water standards.
Okay.
I've had several issues where we've installed them in older buildings, and the strainer plugs up 3 seconds.
Mm-hmm.
I had one the other day.
Did they do a flush of the older loop before they put the new chiller on?
Yeah, they did. They spent like $15,000 with U.S. Water in a treat and cleanup project, but they couldn't get it. So we ended up doing a plating frame to separate everything.
Oh wow. Okay. Climate cool can be, not to interrupt, but climate cool can be challenging in and of itself. We've had to deal with a couple climate cools. One at a building 1521, and their water treatment specs fall outside of the range of standard AWWA water treatment standards. So when they gave us the sheet of what treatment standards to hit, we were like, what?
Well, and part of it too is that it was they're the same standards for the chillers being used for an open or a closed loop system. So they'll have like like hardness.
What they don't explain is most people end up doing a plating frame to separate the loops, and then you just have a small loop pitcher controlling.
Right. Yeah. Okay. Anybody else? Cooling tower problems? I'm about to talk about open loops, so I was hoping somebody had cooling tower problems.
Not particularly.
No. Okay. So types of open systems: cooling towers, evaporative condensers, fluid coolers. Steam boiler is actually considered an open loop because there's evaporation, blowdown, that sort of thing. Water and cooling. It's capable of transferring large amounts of heat, plentiful, readily available, and inexpensive. It's easily handled and does not expand or compress significantly. So that you guys all know the reasons why we use water. And we treat it to avoid corrosion, scale, sludge, fouling, and microbiological contamination, which Dan's going to go into a lot. He's going to talk about Legionella until he's blue in the face.
Yeah, right.
Well, let me see here. So how does water treatment and open systems work? Do you guys understand conductivity or TDS and what a cycle of concentration is? I'm going to talk about it anyway, but I want to know if anybody knows.
I've heard the terms many times.
Okay, so the conductivity of raw water is a measurement of undissolved and dissolved solids in the water.
Yeah.
And we're really lucky in our area. It can range anywhere between 20 and 100. I mean, at the very most, 100 parts per million. So for basic numbers today. I'm going to say 50. You'll have to excuse me, I'm a lefty and it's hard to write. 50 parts per million is our standard raw water conductivity. And so when we talk about water treatment in terms of cycles of concentration, there's an AWWA standard of the cycles of concentration of your raw water to be 120 to 440 parts per million in cycles. Anything over that will create thickness in your water and will create calcium scale. So then you'll start scaling up, and on the back of our cards, I think we all got it, or you guys all got it, on the back of it there's a scale meter that tells you how much efficiency you're losing and fuel costs you're losing based on thickness of scale.
Can you briefly breeze over conductivity for some of the younger guys? Of what your
conductivity, when you have a little conductivity meter, they're sending an electrical pulse through the water, and you're getting what that current comes back, and it's basically measuring what the thickness of the water would be. So it takes into account everything that's kind of in the water itself.
Yeah, it's basically a mineral count.
We're actually
so your standard mineral count for here, let's just say 50 parts per million. In somewhere like Ohio or Michigan that uses well water, their raw water conductivity count could be 220 parts per million. So then they're only able to cycle up twice. And so for them to do open water cooling tower treatment, they need all sorts of pre-treatment. So they're taking their raw water and putting an RO or a softener or a combination of both. Out here, that's not very standard because we don't need to.
We also like to, when we go to our conferences, they laugh at us. They basically say that we basically use DI water. Our water is so pure. So when you're in Vegas or LA and your bleed shuts off, it's a problem immediately. Like scaling is happening now, everyone's freaking out.
Yeah.
They wouldn't notice it for a year here.
they have water softeners in almost every house in Phoenix.
Yeah, and part of a little bit of like what we run into here is because you'll see systems rusting out, corroding out because they're filling with rainwater, which doesn't often take into account for flow control and a lot of other ways that people treat systems, or they're just not cycling up at all or ever running. Mm-hmm. So, I mean, we tend to have these be really low levels. So when you talk to somebody, you say, Brock will probably talk about it in a second, but cycles of concentration. We have whatever your limiting value is. So if it's silica and water or whatever that's going to cause scalar problems, your limiting value is what you use. Ours will be almost always TDS or conductivity, which is those terms are used kind of together at the same time. But when you do a cycles of concentration, we'll say it's that 50 plus is your makeup water in, and then it's what your current water is running. It's divided by that. So if you tell someone, you're like, oh, we run cycles of like 10 to 12 because Jones, Lang, LaSalle, CBRE, they want that number at the end. They're basically talking about efficiency. How often are you bleeding water off? They want to keep the cycles as high as possible so they're not using as much water. Right. So they'll say, well, you need to meet a minimum of 4. I'm like, well, we're at 12.
The problem with that is, yes. Say they want to run 20 because they don't understand. Anything over, I think it's roughly 600 parts per million, and that's when your water starts getting thick and you start getting scale on the pipe. That's why the industry standard's a little lower at 440. So then if you run into a problem, your bleed's not working for a little bit, you have a little wiggle room, and you're not immediately building scale. That's what he was talking about in a place like Arizona or Ohio or wherever. If you're in a hot place and the bleed closes and you're evaporating like crazy, and that's the other part. The cycles build up through evaporation, right? So you have your water molecule, you evaporate off the hydrogen, you leave the minerals. So those minerals just accumulate, and that's what turns the 50 into, whatever, your 9 cycles at 450.
Roughly to keep in mind, while you're at the hall, Kurt, they've got 2 pumps that used to be on a chiller. One of the pumps they ran constantly. The other one, and this was pulled out of some location, the other one sat idle.
Yeah.
And the other one's, the intake screen is just trash.
Yeah.
But the one that was running, good shape.
Yeah, those should be flip-flopped.
Yeah,
they should
run
lead lag.
Yeah, lead lag. They were running a lead lag. So they use that as an example. It's over by the chiller, the screw chiller stuff.
Do you guys have any zero bleed systems or softener systems you've ever dealt with before? No. They're becoming more
like a dolphin,
quote unquote. Well, dolphins, they run higher, but I'm more talking about a softener
okay.
system where they run huge cycles on them. There are major problems with that, and you might encounter them from time to time. They'll basically run softener through the water itself, right? So it's pristine in the middle, and then a Baltimore air coil or a Vapco where they have a treatment on the bottom of it looks fantastic. Only problem is that it eats through the motors in like 2 months because you're using salt water to basically keep it that low. But it's a really common thing. It's a way of trying to get Microsoft in the Eastern Washington and Amazon and Umatilla use zero bleed systems, and they've marketed them themselves. We don't use any more water from it. It's fantastic, except for in those particular areas of where there's farming communities, there's arsenic and whatnot in fertilizer. You can now cycle that up to a toxic level, and you can't get rid of it. Salt is hazardous waste. So there's some of those issues that come around. There's a lot of different ways to treat water that people have tried, but some with varying degrees of success. So anyway, sorry.
Without standard chemical treatment.
Yeah.
Everyone wants to try and be green, and they're finding out that it's very hard. And the greenest thing to do is just use a minimal amount of chemical with building up your cycles of concentration and doing a proper bleed system, and you'll be just fine.
And I should say, he was talking about that water droplet with evaporation. About 90% of water loss in a cooling tower or evaporative condenser is through evaporation and not your bleed water. If you're going through a lot of water, it's because you're...
And that's the other thing. I didn't have it in here. Do you guys have a sewer deduction program here in Portland?
No idea. Most of the sewage in Portland rolls into the wild rivers.
I know.
Well, like in Seattle, for every gallon that you pay to put into your tower, you pay a gallon to go down the drain. That's just the way it works. But in Seattle, they take into account the evaporation. So they measure the incoming water and the outgoing water, and the difference is evaporation.
Through the program, you buy 2 meters and an Itron reader, and they mount the meter somewhere on the roof, and they have the 2 meters, one on your inbound and one on your discharge, where your tower bleed is, and they take the difference and offer you a discount. It might be something worth looking into, Seth, for these guys.
I know Tukwila, Bellevue, I believe Portland would follow the same program, but they would give you a percentage. So they would have an inbound makeup meter and give you 90%. Some places it's 100%. They just figure it's easier to write off because the sewer part of your bill, if you go home and look at your sewer bill, is the most expensive part of the water that you pay for. It's the actual disposal. And so people are like, screw that. If I'm losing it to evaporation, most of it, I don't want to pay for that. So most cities offer some sort of deduction program and it pays for itself. If it's just a little meter for makeup, it will pay for itself that month. If it's, so in different cities, you would be, it's either the job of you guys or the job of the building owner to write down what that number is and log it in, right? The city of Seattle doesn't want to do that anymore, so now they want to sit in their car and have it go by and it's scanned on this little reader. But the group that makes those Itron transmitters are out of Portland. So imagine that there's
It could
be coming here at some point.
It could already be here.
Yeah, that's true.
Right.
Yeah.
Not in our wheelhouse because we're not,
It's an easy sell though. Like if someone was like, I want to, not pay for that, it will pay for itself very rapidly. So, anyway.
Anybody have any questions about cycles of concentration, why we do it? I'm just trying to be very basic on, what our job is when we get called in to take care of and why we do it. Do you guys know, like raw water would just essentially chew through any cooling tower you had, coated or not? A lot of people think, oh, well, it's coated, it'll be fine. But
it's not just a cooling tower, it's where it's going. I mean, you got a roll of water source heat pumps down the line.
Yeah.
Right. Well, if it's just in a cooling tower, it's cycling up over the coil. A lot of that, all of it, evaporative condenser, it's just coated, but it'll chew through that coating like that, and then you'll just start eating up everything, and you'll be covering all the scale. So that's why we build the cycle of concentration, and we treat that with the chemical. We'll talk about the chemicals here in a minute. So, any questions so far? That's why we do it.
You guys want to grab some pizza real quick, and then we'll rush. Sure. You too, Dan? You want some pizza, Brock?
I'll wait.
I'll get some afterwards.
It'll just take a second. It's just right there. And then
Shoot this too.
get it while it's warm.
Do you go for pH? I didn't see that.
Excuse me.
I'm just gonna write up the numbers.
I'm gonna write it. That's part of my. I have to fill up time.
Not that one. Sorry.
No, I figured I'd do this. I figured Ed probably skipped all this.
No, he did, but there was no, you have terms somewhere. It might even be on the next one.
Are we being recorded
Right there.
by someone who's watching this presentation?
No. He's on, Skype thing. So,
Okay.
Yeah, do the, well, I mean, you can go back to what it was before, but I was going to say, they have a,
I'm going to talk about this,
yeah, okay.
just like I did here.
Okay, good. No problem. Ed had them fill out this to use it kind of like your pH should be what? His big thing, I think, when he did it, he went really heavy on the steam boilers.
I'm not even talking about
like they have like a couple of guys that that's their job. So
right.
I was like,
I'm basically, I think most of these guys, other than Seth or Matt, some of the guys we work with all the time downtown Marcus, they understand it. But some of these guys, they do it, but they don't kind of, you bet got to start from ground zero.
So Ed went way over it, and the guy walked up like halfway through it. He's like, "Do you have like a list of terms of like all this stuff you're saying?"
Katie told me that. That's why I did this. I mean, this is pretty.
Yeah.
It's hard for me to write on these things because I just rub right over.
That's what I say. You want me to write it up?
Oh no.
Okay.
No, when it's small, like 50 parts per million, I can do that. But I wanted to write out cycles of concentration.
Yeah.
It would just be a big smear mark by the time I got to the end.
Yeah. And it's 450 divided by 50.
Plus or minus 9.
No, that's fine.
Just ease.
Whatever.
They want to do 8.889 or whatever.
Dude, make it round. I'm gonna get this pizza. I'm freaking hungry.
Time did you leave Port?
Or you left Seattle? I
Seattle.
probably around 11, and I came down and stopped in Tacoma, and kind of hit stop on the way south.
Did you test?
Pork, you need one?
Yeah, probably do.
Pork?
Yeah, it's the scrap that fall off the pizza.
There's one of those strainers.
This is on that Climacool?
One of them.
Gross.
That's pretty nasty. That one was.
Well, that's just a product of putting a new piece of equipment on a crappy old loop that had been cleaned out. And you said U.S. Water tried to clean it and didn't get it all?
They couldn't get it. That piping, it was in a big hospital, so they ripped out a centrifugal and put in a Climacool side by side with the existing centrifugal. And there was several problems with doing that, but that piping was just so old and nasty. They replaced the tower. They tried, I don't know what all, U.S. Water was down there for a long time, but they ended up abandoning that.
The freezer's got more pantry than I do at home.
Wow. And plus, the standards of the Climacool, they'll never hit those.
Right. Well, we hit it for you guys, but now we have a little side note in our book there. It's like, we've hit the number Climacool wanted. This is outside of typical industry standards. That's on you if something happens, because of the weird standards.
A way around it too is when you're adding additives on that for Climacool, if you use a certified lab to do your testing, so you don't constantly have to ship your sample back to them.
Yeah.
If you get a certified lab to verify it for you, they're usually okay with other numbers. So like hardness and stuff. If you're adding constantly now, I smell it or something like that. You don't have to constantly. You pay the $20 on the lab fee, have them verify it, and then they'll be like, okay, sounds good to us.
Yeah.
So you're not redoing everything each time. So,
yeah.
All right. So some problems. These are just a few. You can run into hundreds of problems in an open loop. First problem, lack of treatment. Do any of you know of a water treatment system that you guys take care of that isn't treated? Like, do you have any clients that have a cooling tower that just, they have not put chemicals on there for some reason?
I just ran into one the other day, yeah.
Okay. Have you talked to your client about that?
Yeah. It was terrible. Actually, Davis cleaned out that cooling tower. That Saturday job.
What's their reasoning?
So he was going to follow up on it, and I don't think they're going to.
Okay. Well, hopefully Dan can provide you some Legionella information that if they end up getting someone sick because it's not treated, it's really, I mean, above and beyond the efficiency issues. You see the little bit of amount of scale that can get on a pipe that can affect the effectiveness of the cooling. So anyway, I was just curious. We run into, we treat stuff. I'll go into equipment later, but some people want the cheapest of cheap equipment. They're not really saving money in the long run doing that. But anyway, so lack of treatment. the purities and everything that we talked about associated with the conductivity of the water, corrosion, sludge, that sort of thing. Sewer off-gassing, we were having this conversation earlier. I've got numerous towers that on a big high-rise, they have the sewer vent pipe right next to the tower. So that's something to consider.
They'll land the tower where it can hold the most weight, which is the center column of the building, which is also where they put all the sewer intake, right? So,
right. And another thing that we found too is sunlight. The directional positioning of the tower based on how the sun goes over the roof and how it hits the property can cause a lot of problems. 1521 is a really good example too. They're exposed to a ton of sun, and so they get a lot more algae and biological growth.
So the sun doesn't kill it; it actually propagates it.
Oh yeah.
you know the Baltimore air coils they don't have the fill that's exposed on the side. It's just all enclosed and on like an evaporative condenser.
Yeah.
They hardly ever grow anything except for maybe up on the top, right, where sunlight hits.
Yeah, you're right. Yeah.
But if you think of like the newer Marley ones that are now like it has the fill like this, the little trough here, fill is kind of like this, and you have the big trough back here. Those have a lot of problems, mostly because you have your sump pump here, goes over, right, and all this fill right there is facing direct sunlight. It all grows on the edges, so your water can look fantastic. The edges is growing crap all over it, right?
15.
Plus this sump right here gets almost no circulation. So you inject chemicals here, and if this little sump water right here is hoping for passive flow back into here, nothing's protecting crap in there. So you get a nice little pool to grow crap.
Sidebar for that though, when they sell you this tower, there's a piece of equipment called a sump sweep that they want to sell with that, but it's usually anywhere from $10,000 to $50,000. So the client's like, no, we don't want that. And then they don't realize that they're not getting proper circulation because this is actually designed for a sump sweep. So on the tower that I keep referring to, 1521, we built one. We just bought a large sump pump at Home Depot, and I had Matt White build like a PVC octopus that pushes water out to the front, and it's helped keep it's at least helped keep the back clean. The sunlight still creates all sorts of problems. He was pressure washing it today. So anyway, some things to keep in mind. You should take that to your engineers, Seth. Tell them to quit facing them to the south.
Yeah, I'll do that.
Chemical treatment, key measures. Some of the things we measure in an open system, pH. Just test the neutrality of the water. So raw water is 7. So
Here, raw water.
Here, yeah. What we test industry standard 7.1 to 8.5. You just want it slightly alkaline. You don't want it too heavy. TDS, we already talked about that. Or conductivity, same thing, just a different way to measure. Industry standards 120 to 440.
When you were talking parts per million earlier,
Parts per
million of what? Parts per million of mineral?
It's a measurement of particulate in it, yes, a measurement. So it's TDS stands for total dissolved solids. So it's parts per million in dissolved solids.
A part per million in the water. So it's a physical count of what's in that.
And those solids could be mineral?
Yeah.
Or
calcium in the water.
Iron, calcium.
Magnesium and calcium make up most of the
And
calcium.
silica.
Yeah.
Silica's a big one.
Sand, yeah.
But and then 660 is really the very end of the threshold before it starts falling out of solution and calcium will start forming scale. Calcium.
Right.
So,
but the industry standards, they keep it low. Just like I said, if something happens and you go a little higher than that, you're not going to run into it. They don't want to set the standard at where water gets thick and create scale, because then you're just going to be fighting a battle. So, hardness.
Calcium.
It's the same unit of measure.
I hate rule of thumb, but in general, it's about usually 2/3 of your dissolved solids will be calcium.
Mm-hmm.
That will vary, and actually
it's strange. You would think building up calcium in the water would hurt it, but it actually pacifies the water and the metal to a certain extent. And then when you cross the threshold, then that's when it starts to coat stuff with calcium scale.
And in closed loops, you want hardness to be 0. You don't want any sort of potential for heat transfer.
We're talking about open loops there.
But I'm just saying that on an open system, we actually use it as a buffer. as part of your calcium. It'll increase, if you see a higher number in hardness, you'll see higher in TDS and pH as well. You're also using less of your inhibitor chemical. And so most systems, when you're brand new, it's a bunch of raw water, it's why it rusts out. You can get some of that calcium once it cycles up a little higher, working for you. So
Preventing rust.
Preventing rust, yeah.
Right. Thank you for the introduction. OP, organophosphonate, is that's the chemical that we actually use in our inhibitor. So our cooling tower chemical, CT100, it's a rust inhibitor. The OP levels, we want 3 to 10 parts per million. Anything less than that, and you can have corrosion happening. Anything more than that, and you can actually start building chemical scale. So if you over-treat your loop, so this is a really important number to keep track of in water treatment, because if you're over-treating your loop, you can actually get it. It's kind of it almost looks like calcium scale. It gets like white and sludgy on your stuff. So these are the main tests that we do for cooling towers. And then I think on here, well, we also do microbiological indexing. Dan's going to talk a lot about that, so I'm going to skip that. We already talked about Pacific Northwest water tendencies. We're really lucky we have really clean water here. Temperature, it's using steam boilers. I don't think any of you are taking care of steam boilers. I don't have any information on here.
No, but I thought it was, yeah, sorry to interrupt, but when you guys were in Seattle talking about steam boilers, about treating the steam, because the chemicals actually go into the steam and then up through the pipes.
They can. If you over-treat a steam boiler, you can get carryover. So you can actually carry the chemical in the steam. So if you're in a food plant, you have to be really careful about what chemicals you use.
We also use traditionally cyclohexamine so carbonic acid is formed in your steam, and as that's come back through, it's usually returned back to your makeup tank. A lot of times, not always. The process is not always. But you'll use a treatment of a chemical called cyclohexamine. It's really common, or a filming amine of some kind. That is meant to carry over in the steam and protect the pipe. Now in food facilities, they're now eliminating that. Even though it doesn't affect taste or anything, it's got a strong odor to it, but it doesn't affect the way food consumption is. But they're eliminating it, and they don't actually have much of an answer to what they can use to.
Old standards where you could have up to 10 parts per million cyclohexamine readings in your steam for food grade facilities, and you'd still be okay. So now they don't want you to have any.
And a good way to look at that is like when you guys have your the boilers that have the condensate drains, it usually goes through the canister of lime, right, to neutralize it. And if it runs out of that lime, it eats away at the pipe. Well, I mean, that's basically, if you're running the purpose to carry that steam to the rest, it would do exactly the same thing. Only you don't have lime. It's just the straight carbonic acid going to it. And they need to use that steam. So putting some groups, they're like, we're just going to put stainless steel in. Or they'll just say, screw it, every few years we're just going to redo all of our steam piping. So, anyway.
Right, so what does it all mean? Basically, if you have a proper water treatment program that's taken care of the right way, you're going to have a safe unit, you're not going to get anyone sick, you're going to maximize your efficiency and eliminate a lot of wasted maintenance time. So for us, frequency of water treatment visits, we're there at least once a month. All of our open cooling tower clients, we're there once a month, except for like large ones. We have AT&T. They have, how many towers do they have, Dan? Like 9 that Ed does. Yeah. And they're huge. They're on this elevated platform. He has to go once a week. Everything's tied into a computer system. They graph everything. They want them there once a week just to make sure everything's good, because they want to run the most efficient system they possibly can. So at least once a month, if you guys have water treatment providers that aren't doing that, you should ask them why. Because these things need to be checked, or it's really easy to get out of whack. So what can you do? Specifically especially with clients of yours that don't take care of their towers, OSHA standards, they want you to clean your towers twice a year. And so if they're not doing that and they don't want to pay to do that, and then they end up getting someone sick with Legionella or something, OSHA's going to be down your throat and their throat wondering why you guys weren't doing the job. And then in the wintertime, you can drain your towers that might not be getting used, because if you don't, it's just going to sit there and become a pond. We can throw in all the chemical we want, but if it's not getting circulation, it's not going to treat the water. It's just going to settle out in the bottom of the tower, and you're just going to rust out the pan of the tower anyway. Different treatment options. As I was saying earlier, there's a multitude of options you can use. You can just do like the cheapest option, literally, is to go to Home Depot and buy a $20 outdoor timer and plug it in and program it to feed in chemical. And then you would do what we call a manual bleed off the drain. You just crack the drain valve, and we always use a pin width as the unit of measure. If someone's like, hey, it's not bleeding, what do I do? Just blow it down, then close it back to have like a pin width of water. And that's it's the cheapest equipment option, but they're spending so much more money in wasted water because they're constantly having to bleed water off when it's not necessary to keep their cycles of concentration down. So you can also do the same thing. You can take that outdoor timer that's doing your chemicals, you can put it on a solenoid. So then they would have to buy a solenoid and another $20 timer, and then you can program that timer to open the solenoid full, bleed out. So save you some money, but overall you're still losing quite a bit of water that you don't need to. pH controller and a TDS controller. Most of the controllers we use have the function of both pH, TDS, pulse. Yeah, I don't know why they're all listed out like that. Most of the controllers that we sell that we like to use, they can measure your pH, your conductivity, and then they have a bleed function. So you wire your solenoid into the controller, and then it's this kind of all-encompassing computer really that runs your treatment. So then we come once a month, make sure the settings on the programming are correct, and that your bleed's not fogged. We'll check the strainer on the solenoid. We'll go through all your equipment, make sure your chemical levels are up to par, and then we'll write a report. So we can get you a list of equipment too if you guys are interested in updating some of your accounts.
One of the questions that came up before was, how do you, like, if you have a condenser water loop in a building and it's not treated, you find out that it's not treated. Like
An open loop?
Well, let's just say it's a closed loop.
Okay.
Like as you're getting into, and you're new to the job. You take a water sample and you send it in to you guys for testing. Turns out there's no chemicals in it, or it's very low. How do you find out? Like, how much do you put in? Like, where do you even know how to start? Like, how much chemicals should you put in there?
Well, we would. It's kind of a guess and check at that point. If you don't have a piping diagram that can tell us how many lengths of a certain size of pipes in there, if we have your piping diagram, there's a pipe capacity sheet and we can do a calculation. But if you don't know, we've been doing it long enough to where a certain size, condo building, 10-story condo building with 6-inch pipe, we're going to
kind of guesstimate.
Yeah, it's going to be somewhere between 500 to 1,000 gallons. We kind of know that. So we'll start at 500 gallons and then see what the chemical does. It's kind of like we'll add and then test, and then we know how much chemical we put in and what that's supposed to treat, and then we take that ratio and then figure out approximately.
And it depends on every water treatment company will have a set standard for this 5-gallon bucket treats 500 gallons or 200 gallons or whatever. And then most of there isn't a whole lot of secrets in water treatment. Everyone pretty much uses the same type of chemicals for the most part. So even if they use Tracer, like Nalco uses a Tracer product, that's just a color metric in the water. But they're using phosphonate to treat it. The color metric's not doing anything to treat the system.
Say probably 95% of cooling tower water treatment is phosphonate.
Yeah. And so nitrites are predominantly used for closed loop systems. Most groups have a sodium nitrate chemical that they sell. That's most often what's being used in closed loop systems. And again, like our 5-gallon bucket treats about 250 gallons of liquid. Some groups, make it more, it treats 500 or it treats 100 or whatever. So right. Sometimes it's listed on the bucket.
Or
otherwise you just can contact whoever the water treatment group.
A good thing, if it's dirty, you could drain the loop completely and then fill it with a flow meter, and then you'd know.
That's a good idea.
I mean, if you're already doing a running flush anyway, if it's really dirty, hasn't had treatment in a while, and it's muddy, and you flush it out anyway, just do a running flush, and then when you fill it, dump it, and then it might not be completely accurate because some of your horizontal lines or coils aren't going to drain all the way, but you'll get close enough to know, especially if you're going to put glycol in it or something. But that's the other way we can do it. Some people want glycol and they don't know how big their loop is. We'll add a drum or two, depending on if it's a massive system, maybe we'll add 5. But if we can affect the percent of glycol by 3% or more, then we can get it almost to the gallon. because then we just do a simple math calculation. If X number of gallons of glycol made it 3%, then you divide it out, and then that's how much more you'll need. So different ways of doing it.
Have you guys ever added chemical to a loop? You know
Just glycol.
what a pot feeder
I
is?
tried.
Pot feeder?
How do you add your glycol?
This was an open loop, so I was able to just pour it right in the top.
Oh, it's like a brewery chiller type thing? Yeah. Okay.
There's a bypass feeder that's really common on systems. A lot of Wingert sells them, and a lot of them have filters in them. They have 5, 10 gallon, 2 gallon. Anyway, when you got your pump, you get your turn.
Where is it?
You'll see it tee off
right there.
right here to a full feeder. And so it's considered part of your loop, and you're not losing pressure, and you're not adding air, which is key. They usually have a little valve here, it's big enough. So you're at it. You can add nitrates that way. You can add glycol that way, but it's a giant pain in the ass. You pump it in the system. That way easier.
I think there's a glycol pump here.
There is, I've used it on a Libra.
We have a big gear pump that does a drum in 5 to 8 minutes that we do a lot. That makes life easier. Otherwise, some groups like that. The way to do that, keep in mind, if you're ever adding glycol to a system, you just want to make sure makeup is off, pumps are off, and you're bleeding roughly at the same rate you're feeding. And then that's the easiest way. Couple of those get
Yeah, on the pot, so like on that pot feeder, you're using the supply pressure off the discharge of the pump to circulate through the pot feeder. So what's nice about those, like Dan said, is you valve it off, you drain the water out, you fill it with chemical, put the top back on it, and turn the valves on. So you're not introducing air, and more importantly, you're not adding volume to the loop. You're not adding an extra 5 gallons. You're taking out 5 gallons of untreated water and adding 5 gallons of treatment, and then letting it circulate.
The fun ones are the ones that stick a valve right there and put it in the supply line or return line. And they are intending for you to decrease flow to force it through from, say, a 4-inch line to a 3/4-inch line at a rate that isn't going to start your pump. That was a really common way to do it in the 70s. And you will see it on a lot of buildings. And it works.
Just don't isolate the valve all the way.
Watch your pressures here.
Yeah.
But anyway, that's a really, most of them now, if they're installing new construction, they have one supply, one return. All you need is 5 PSI pressure differential to get flow across the bottom.
And I believe Dan made a mess of this. I believe I might be backwards here, but if your pot feeder is here and you have a supply line and a return line, I believe the pot feeder or the filter, you have a filter media in here and it hangs down, right?
Yeah.
And there's like a seal right here. So the filter media wants the water to go from the outside to the inside. So if you're plumbing one in, you want the supply line down here. And you want your return line to be up top. Does that make sense? Because you want to filter from the outside in. You don't want to, if you plumb it the other way, if you did supply here, you'd be sending all your particulate into the middle of the filter media and then trying to push it through, and you can actually explode the filter media. And then it's a huge pain in the ass to get it out of there. You gotta get one of those like automotive tools to get to the bottom of it, because this is the dome bottom of the drain.
Yeah, I've never seen that one. The ones I've seen, you want it the other way because the filter is just a cloth filter.
Yeah.
And it's like a sock filter.
Yeah, on almost all the bypass feeders, they ship it out with a diagram. Pay attention to whatever it's got supply and return, because you're right. It's got a sock filter in it.
Yeah, it's got
to want to catch that crap.
Yeah.
And yeah, a lot of the newer ones now that Wingert sells, they're actually, the sock is in it.
Would that be like a cartridge filter, like a pleated?
Yeah, they have a pleated paper. We do 5 and 20 micron, I believe, or 5, 10, or 20.
They can do any range.
But what we really like, those fail, even if you plumb them the right way, if you have enough pressure. So we like to use string wound. It literally looks like someone used yarn or something. It's just string, and they do a much better job, I think. Do you know what the filter, the micron level gets down?
That's 20, I believe.
Is it?
Those ones, yeah.
Doesn't go to 5.
No.
Anyway, so yeah, I guess good point. If it's a sock filter, you'd want it the other way, but we don't run into many sock filters. So, different types of closed loop systems: heating hot water, chilled water, reclaimed water, closed condenser loop runs through the other side of a chilled unit or something. And then water and cooling, kind of the same thing as the open loops. And then we treat it to avoid the same things. The difference is we're not creating cyclic concentration through evaporation. We're creating it simply with our chemical addition. So with our chemical, I don't know if we have a... so with a closed loop, you're not doing this one, but you're doing pH, TDS, hardness. You also measure alkalinity, and that is 120, 250. And you guys don't really need to do this. This is more just what we do. And there's total, and there's available. And then, total would be, I'm sorry, available would be 120 to 250, and total would be double that. And literally, you just multiply by 2. And it's basically a variation of pH, and it's telling us that we've created a buffer in the water to allow the water to be pacified and the metal to be pacified. That's basically all it's telling us. But we generate all of these readings through adding our either nitrite or phosphate chemicals. There's other chemicals. There's molybdate. It's kind of being phased out. Seattle's, is it illegal yet?
Not yet.
It's going to be illegal. It's very toxic.
Molybdate's commonly used in, it's used in fracking technology too, but they cannot separate it out of the water treatment process of the facilities. And so they consider it a heavy metal particulate. In King County, they've asked for it to be a voluntary reduction of just using it because they know only really water treatment companies use it. And so that can you please stop? But it's nothing that's been legislated yet because it's in so many different water treatment chemicals. And so anyway, it's something that they will be looking at, I'm sure, changing them.
Right. And then, did you have
I was going to say, and something about that too, on like some cities monitor sewer chemicals.
Yeah.
Like they'll know if you dump a loop, a water loop in a building.
If it's massive, yeah, they'll
know.
Especially if it's ethylene glycol.
Most of the time we've called, and most of the time if we're not dealing with ethylene glycol or molybdate, they will love us because sewage is acidic. And most everything we're putting in. The pH of a closed loop, this is for a cooling tower. The pH of a closed loop.
Just go to the left.
Hey, smart guy. They want 9 to 11, so it's even higher, right? So a lot of times you'll call about discharge, and they'll be like, that's great, because our acidity level here is 5 or 6 because of all the sewage. So we add that, and we neutralize their system for them. So it's usually not a big deal unless you're using molybdate or ethylene glycol or that sort of thing. But still, if you're dumping a large system, you probably should call the municipality in your area. So what can you do? Dan and I went over the filtered bypass feeder. They're really great at helping clean up. And if you do add those to a system that doesn't have them, the best place for it is the lowest place. The heavy sediment falls, and even though you might have a lot of velocity with your pump, but still some of the larger sediment's always going to stay at the bottom. So the lower you can get your pot feeder on say you have a 10-story building, if they want to put it on the roof, say the mechanical room's on the roof, but you have access and mechanical space in the basement, it'd be best to plumb in the basement if there's a drain and stuff. So something else to keep in mind. And then water treatment visits for us, it kind of depends on the client. It's usually quarterly or semi-annually unless they know that they've had a catastrophic loss. If there's a flow meter on the makeup water and they've gone in there and it's spinning, or they've seen that, sometimes there's a log by the flow meter that'll show what the last reading was, so then they can check it and see if it's lost any water. And then you can do lab analysis like iron bacteria, stuff like that. So, any questions so far?
What's iron bacteria?
It's in all makeup water. Everyone here consumes it. But it used on. Do you go over glycol or want to go over glycol?
Not
in a
really.
second.
Oh well, I can't remember.
So on glycol, there are two different glycols in a system that you almost commonly see. Ethylene glycol is what you put in your truck, right? And it kills all sorts of bacteria. Well, that used to be totally used as the number one glycol in the system. But ethylene glycol kills all the bugs at a sewage treatment facility as well. So now they've eliminated it almost everywhere that you can do it. And you see propylene glycol. Propylene glycol is in your shampoo. It's in food products all over the place. And inhibitors. Well, iron bacteria is fed in your water normally, and that bacteria feeds on propylene glycol and inhibitors for food. So if you open up a loop and it smells like garbage, that's the byproduct, the waste byproduct of bacteria growing in it. Most often that is iron bacteria. You can stick in, even though you can't stick in ethylene glycol, you can stick a product called like glutaraldehyde. A lot of water treatment companies just call it closed loop microbicide. It's really nasty stuff to deal with. Don't go huffing it or anything or getting it on your hands because you're a giant organism that wants to kill you as well. But glutaraldehyde kills iron bacteria. And it's iron bacteria is found in all water, all makeup water everywhere. There's so much bacteria in common water that is never filtered out everywhere, that including Legionella, that you in a closed loop setting, whereas most of those bacteria would die off because there's no sunlight. Iron bacteria with 2 parts per million of iron in the water thrives.
That's why treatment's important. Because if you create a high alkaline environment and you don't give it iron to feed on, they'll die.
And one other kind of side note on glycol, if you have above 24% on glycol, it makes it significantly harder for bacteria to replicate. So you don't get as many bacterial growth issues if you have glycol above 24%. It's expensive, but if groups are looking for that. And in glycol, really what we're looking for is freeze protection, but there's heat transfer properties with that. So and you'll see it specifically to MRI chiller machines. You'll see it 38% ethylene glycol. That's got a heat transfer property that they're trying, a coefficient they're looking for. If you're doing data facilities, they want 0 glycol because they want to reject as much heat as possible. It gives them the most return. They're trying to get rid of as much heat, and glycol will hold that heat in for a longer period of time, any amount. So most systems, especially on what they're not worried about freezing because they have heat all the time. If their systems will ever go down, it's just going to be a catastrophic failure. So they'll put their generator systems, they'll tie their pumps into it on most data facilities. So
you guys do any big data facilities down there?
A few of them, yeah.
Most of those big data ones, most groups, most buildings. The question you might want to ask on that is, I guarantee they don't have glycol in it, or they don't want it in it.
I was going to bring that up later.
I have quite a few data facilities with glycol.
Do you? Well, most of them
that
are.
big one.
Oh, okay.
We put in like
That's true.
40 drums or something.
That's true.
Yeah.
Most of them, though, if they're doing heat rejection through like a cooling tower, I should say. Honestly, some chilled.
Yeah.
Well, it's an easy, what in my experience, what happens is they design it because they want the freeze protection. They design it for glycol because they don't want to freeze their dry coolers if it's a dry cooler or whatever. Yeah. But then what happens is the data center grows, they add more units, and now they need more capacity. Well, they don't have the roof space to put another dry cooler. So what do? Well, they take out the glycol.
Yeah.
And that it basically increases the capacity.
And especially on dry coolers, the tubing's so small, they're drawing air through it. On a cold day, it'll snap it like that if there's no glycol in it. But on kind of like the bigger fluid cooler systems where they're constantly getting flow across it, they want to try with a fluid cooler at the base of it. They don't want that glycol holding it, that heat in there for longer. But yeah, I guess it depends on how it's engineered.
Yeah, right.
So this is a list of our standard Chemtech chemicals that we use on open and closed loops. I'm not going to bore you and read it all. We've talked about having some place down here to have a storage facility for some. You know, if you guys have clients that need water treatment needs and you want to start using us, we can definitely get some inventory down here for you and help you out.
Yeah, like in Seattle, Chemtech's done chemicals for McDonald Miller for, I don't know how long, 20 years?
Probably.
And so like, at least for downtown, the way they do it, we have at least one guy, normally 2, that does chemical testing. He's just a standard McDonald Miller service tech, but he's got a kit. He can do some quick little tests on water loops because he can get there a little faster. But then we stock, and do you guys stock his chemicals? or his water treat or his test kit?
I think in the past what we've given is just, this is our discount number, just call them and order it and drop direct ship to yourself.
Yeah.
Just so it's easier for them.
So like, and
we
then we stock Chemtech's chemicals in the lower building. And so like, if we need to add chemicals, we just grab the chemicals out of the storage.
So instead of calling us in and paying a fee, if you're just draining a boiler or a chiller to do an inspection or something, and you know you need to boost it a little bit, they can just go grab a bucket of B500. You know, call us and be like, which chemical is it? If you have a question, and then you know you can just go dump some in.
Yeah, so, makes it easy.
Yeah, it makes it real easy. So anyway, there's a list. So I went over this. We test monthly for the open system. Closed system, it's up to the client. It's usually 3 to 6 months unless something happened. Or if the client, you know, some clients want once a month. You know, if it's a data facility and they're being really picky, they want a monthly record on what's going on.
And we like to test closed systems usually like right in the fall, because then we can let them know whether they have freeze protection in it or not, and it's got that impetus.
Yeah, September, October is a good time because then you got a couple months to get approval to get glycol in, that sort of thing.
And then, or in the spring, because during the summer, if it's on a chilled system that's going to be running all the time, that's a good time to add something. Or if it's a heating system, it's your last chance before it's not going to run for a significant period of time.
And then Rob, you said you have a hydrometer?
Yeah.
Or a way to check
Glycometer?
Yep. Yeah, perfect.
Yeah. Okay.
Those are great. Everyone should have them. They're not expensive. And
I don't know, this one's pretty spendy. I can bring it in for you.
I'll say this: the cheap ones break at the same rate as the expensive ones, because we break.
Show
the
them yours,
expensive
Dan.
ones.
You got your X-Tech in
there?
It's an X-Tech. You get it at Granger for like $150.
I think it was 44.
Yeah.
Your X-Tech?
No way.
These ones.
I just requested the tool room get me a damn hydrometer.
They have a
Yeah, that's the one.
yeah. They have
$100 RSD.
the X-Tech ones are the more expensive
Those are
ones.
cheap.
Yeah,
RSD.
those are, and they work great.
Is that not X-Tech?
No, X-Tech's the.
What you do
well,
is you
maybe
take a
it's
sample with the bubble,
No.
put it in the.
Anyway, yeah, they're
glass, hold it
cheap.
up there,
Yeah.
and it tells you what your bubble is.
Oh, that is that one? Oh, yeah.
I mean, at the most, they're 100 bucks, 125, but for what you can do with it, I mean, like.
I mean, you can get
there's
digital
the buy
fancy
into
ones
it.
for hundreds of
Yeah,
dollars.
yeah.
Yeah,
No,
and
that's-
Ed's got a digital
Right.
fancy one that he dropped and it
That's
broke.
boring.
And it's like, great, there's,
My van bounces down the road
$700.
every day.
Right, yeah. So,
They did 300
it's,
Can you try it?
so
See how it
the
works.
same,
I'll get some water.
yeah.
Well, you have
same-
glycol?
Oh, yeah.
You have loop water?
Let's do regular water. It's
might
fine.
even have some
Glycol
glycol
right
out there.
outside.
We got a glycol barrel out.
Actually, grab some soda.
So,
Yeah.
okay.
I'm curious. I'm gonna do a little.
You want to see how much acid in it?
No, it's sugar.
Sugar.
Sugar it's measuring the same level. So if you had a fruit farm or whatever, and you squirted some on there, and you're trying to find the Brix count to turn to, say, alcohol, you would find out on a refractometer. It's just measuring the amount of sugars that are in a particular solution. Glycol is no different. So I'm curious. This is pretty good. But
That's how you use it, by the way. too.
so what you would really do is just put a little drop on it, look it up, and then look at the sunlight. And this is about 14% if you're going to measure glycol. It's sugar. You're measuring sugar.
Yeah.
And
The
so,
blue line versus the white line, and then it'll give you the reading.
So then 14%, and how do you
so if your
calculate?
system was full of Sprite, you would have a freeze protection.
14%.
Yeah. So that's all you're really doing.
I'll use it next time I get in the woods. Oh, so what, you're looking for where the white
So it's where it's the
blue?
horizon line. You'll see. So where the white and the blue meet, that's
Yeah.
your reading.
So that's down at the bottom, almost.
Well, it was right at 14 when I first got it.
That's the same one Sean's got. I think mine's different.
Yeah.
Yeah, and then you can try a second. It didn't look right.
Yeah, it's where the, so if it was just white, and you can use this to alter for your eyes
So
too.
you still have the clear water in there stuff?
It's soda.
It's soda.
Calibrate it. Oh,
Yeah.
I know how to do it.
Yeah, so,
I was gonna say we could calibrate it with the clear stuff, so that way.
oh yeah, the
This
little,
guy-
yeah, that's right.
He's newer in the field, so that's why I
Okay,
kind of
the,
try to inform him a lot. Sorry.
the very bottom horizon line, the very bottom line that's there is 0%. That's fresh water, basically, 32 degrees freeze point. So 20% glycol is about 20 degrees freeze protection, 19 degrees or so. And so 30 is about 10, and 8, yeah. So unless you're in Alaska, you're not seeing much above 30. Most systems are not engineered for pumps to push that thick of a solution. When you do an actual hydrometer test where it's floating in the solution to figure out where your sample reading would be with the little bulb on it, you're really just figuring out how the specific gravity of the water, because glycol is heavier than water. So when it's mixed together, that's what you're looking at.
I think so.
It goes all the way across. It gives you a measure of propylene and ethylene. There's like a divider line in the middle.
Yeah.
I think it's right side propylene. So if you're measuring, you have
So where you see the
glycol.
blue.
Yeah, on the right side.
Yeah. Well, so propylene's on the right.
Ethylene
And
on the
ethylene's
left.
on the left, yeah, and it probably doesn't have, see, it's not all the way on there, but you gotta look right.
Oh, there we go. Yeah, covered.
Yeah.
For sure. Oh, shit, now it's clear as day.
Yeah,
Yeah.
It's just that there's also bubbles in it,
which don't really help.
Carbonation.
Don't put your, and don't
It's
put
not
your
made for carbonation.
Yeah, because
Right.
the light is shining through that prism into your eye, so that's what you're reading. You want as much light into it as possible.
The system has no glycol in it.
All right, I need to finish up.
Yeah, you can watch that. Yeah, go ahead.
Um,
Drag it much longer.
So anyway, typically, when we go to a site, whether it's open or closed loop, we take a test, we write it down on, this is our test sheet, we write it down, and there's a copy for us. We take the yellow copy for our records, white copy stays.
Did you get to see it?
We put a placard on a wall, we have a book, so there's a log of everything. If you ever have any questions about what we do, you can flip through the book and see what we've done in the past.
Well, it depends on.
We test anything related to the treatment side, we'll test it, or we'll check like the strainer on the solenoid, make sure all the valves are open.
Same thing.
That sort of thing.
George Brown.
SDSs.
I mean, they're all pretty, same
That's a
deal.
$44.
All right.
So what's what do they spec for freeze protection generally around here?
Well, it's up to,
I would say specs are 25%.
Isn't that up to the engineer?
But I mean, like,
Yeah.
number, like, is that 22?
Absolutely.
yeah, we
22?
can't,
customer
the
wants.
problem is, someone will ask us, we can't give a recommendation, because say, well, it never gets cold here, we'll recommend 20%, and then we have a cold snap and their pump stops, well, then they break a pipe and that's our fault. So we always defer to either manufacturer's recommendations or your own preference.
So 20% is what, like
20 degrees.
20 degrees?
Yeah, 20 degrees. So it'd have to be cold
Stagnant
for
water.
a long time.
Stagnant water, and that's the internal temperature.
Yeah, so if your pumps aren't running,
Right.
so we always just defer to manufacturer specs. Like right now, we did a project at Costco Optical in Auburn. They wanted 20. They gave us system volumes that weren't correct, and we got up close to 27, I think, on one of their fluid coolers, and the pumps that Trane put on their fluid cooler weren't sufficient. So it's just moving through there like sludge, even though it's not even 30%.
Oh.
So we had to go out there with drums, drain the system down, and let it fill back up with makeup water to get it down to 20%, and it's still not fast enough. So now they have to have Trane come out and replace the pumps, because the pumps
It's just so thick.
well, they just undersized the pumps for the type of loop that they. Basically, it was poor engineering on Trane's part. So, anyway, yeah, we usually defer to a lot of equipment now will come with some sort of spec. This piece of equipment will operate best at. Some of them are weird, like 22.5%. Okay, I'll try and hit that.
MRI chillers, 38 on the nose.
38%.
38%, and I moved the system.
there.
I moved the system out at Covington Multicare. They moved an MRI chiller right outside to across the parking lot to then right up above it. So that was all ethylene glycol. I had to capture it. This is really critically important with ethylene glycol. Ethylene glycol you can dispose of. You can recycle it if it's above 15%. If it's somewhere between 8% and 15%, you have to use solidification. It's $2.75 a pound to dispose of. And so I had them remove 4 totes. Because totes of liquid. Totes are 330 gallons each. Because you needed all the ethylene out of it, which I did, and I drained the system completely. Then I had to refill it and flush it, but I can't just send that flush down the sanitary sewer system. So I had to capture that as well. So I was hoping to be caught somewhere in between, and not in that middle range.
Yeah.
And so they were able to recycle a chunk of it and then dispose of the other. But it was twice what we were charging for the project.
through impulse services, really. And but yeah, anyway, that's ethylene glycol. Propylene, most systems have propylene glycol. It's really easy to dispose of.
So how do you know the difference? How would you? Because
You have to take a test.
Yeah,
You can't know by color?
No, color is only thing color is a dye, and every group is different. So is Dow using the same color as Cascade in Tualatin, right? Who knows? And so when they ask for dyes, all that pink that's in there or the light green, that's just that's true. That is like what it's an additive. But you know, Chem Aqua uses pink for their nitrite dye. I hate dyes. You can't do a proper alkalinity test with dye in it. But everything's just got a dye in it. The true way to figure out what type of glycol is you have to grab a sample and go have a spectrophotographer do work on
I have to send it in to you guys?
We don't actually do it. We send it to a third-party lab because it's got to spin until it reduces out. And
It's
then
like a $20,000 piece of equipment.
So,
You have to write-
but there are labs all over. I mean, there's a lab in Portland that'll do it. We're trying to track some of that stuff down just to have some more local representation here.
I've been picking up a lot of MRI chillers, and
Yeah.
they don't say I haven't found any documentation on what's
Propylene
in
around
there.
there. Yeah.
And then I got one data center where they're interested in what they have. So
Grab a sample. There's a couple of groups that definitely do it. There's a lot of labs that are local. There's one in Tacoma that we're using that's pretty cheap, you know, relatively cheap for finding out what it is. The bummer of it is that Dow used to do it for free. They used to just grab a sample, you could drop it off at Dow, and David Kwan, who was there, would tell you later that day. And he was always spot on target. And now Dow's like, screw it, we're not doing it anymore. They did it for anybody, regardless of what chemical was in their system. They said,
If you buy a lot of Dow, they'll do it for you for free, but we don't use Dow chemical because it's very expensive.
Well, no, I mean,
So
we
they
don't.
get mad at us for going in there.
They let him go. They let their lead chemist go, and they brought everything in house. So David's not there anymore, and David used to just be like, "Yeah, sure, I'll test it." So, and he was in Kent, and so now you actually have to pay for a lab to do it, but it's not the end of the world. It's important to know on disposal, because what Seth was talking about, like if you send it down a sewer system and they can trace it back to you, that's bad. But what they often say is that you can't dispose of ethylene, which is partially true. It's a really low amount. What you do is a thing called BOD test. It's biological on demand. That's really what the sewage treatment facility wants to know. They don't really care what's in the water. They want to know if you're going to kill off their bugs. So if it's at a low enough level that's not going to impact them, they may give you the okay. Because they'll say, hey, we're getting all of this, sewer treatment water from Portland that's going to mix with your limited amount that you're giving us. We're not going to see anything. That's something that they'll want to know. But if you can qualify that ahead of time, at least in most municipalities, you can say, hey, my BOD is this, my quantity is X, this is what I know is in the water. They go, this is the date I'm doing it. If this is the rate I'm sending it to you, they'll be like, go for it. So I think, and they do. They even when you call them, they log it. But when I last talked to the King County one, they're like, you guys are like the only one that call us about this. So, people just end up sending it down. But believe me, they know when you're dumping a swimming pool or whatever. So anyway, it's at least a little bit on disposal stuff. But most of them are pretty easy to work with for the most part. When we went to our water treatment conference, it's in a different city every year, and it's in September. The last 3 of them have predominantly been about Legionella. There is a new ASHRAE standard called 188, and I'll get to that in a second, that is going to require a water maintenance or a water treatment program or water maintenance program for each building in hotels and hospitals. This is undoubtedly going to fall down on you guys. So Legionella, as you guys kind of remember, I'll go over both New York and UW, where they had outbreaks, is what the big scary bug in the room when they're talking about water treatment. So what is it? It's a severe form of pneumonia contracted by inhaling water droplets containing Legionella deeply into the lungs. It's important to know, where's that? Nice. There. Inhaling. Most people are like, it's an outbreak. It's not an outbreak. It's not the flu, which significantly more people die from than Legionella every year. you have to inhale the droplets of the water into your lungs. And that's why cooling towers and evaporative condensers are the ones that everyone looks at first. Well, it's spraying water everywhere, and that's what's getting in our lungs, which is partially true. What is the primary source of Legionella cases? Potable water. It's almost, in the UW case and a lot of the other cases, 60% of Legionella cases, may even be higher, is from potable water systems. As they've lessened the temperature in hot water systems, they're not killing off bacteria. And if hot water systems are sitting stagnant by themselves and get introduced back into the main system, they're finding that's really common in hot water systems now. And then also, the water that's entering the building does have small amounts of Legionella, but for the most part, where Legionella is being found is in the taps, the actual little filters at the tip of the tap.
On the screen.
On the shower heads, that, especially the U ones that go down, or in ice makers, where water's pretty stagnant for the most part.
Ice makers are gross.
So when you go to grab a drink of water from anywhere, run the tap for a second. And you'll
Well,
be
no,
all
that's
right.
important. I don't know if you guys have seen the news before. The public schools is really being nailed right now for their lead in the water.
Yeah, and lead is,
It's all at the faucets.
and or whatever mains are, depending on how old they are. They're iron breaking down. They use lead as another component part to it. So lead is also, in the Flint, Michigan case, lead was specifically tied into a water sourcing issue. They switched their water source. They didn't want to buy it from Detroit. So, and Detroit had more pure water. So they took it out of a well that had high levels of lead. Legionella, 90% of the illnesses are caused by a single species, Legionella pneumophila. Again, inhaling it is how you get it. It's presented in 30% of all homes, up to 80% of all air-conditioned cooling towers, and up to 50% of all water systems in large buildings. In your cooling, it's in all of your cooling towers, period. When you're doing a test for the OSHA standard for the test, and we'll also get to that, they'll take a number of faucets for domestic, and if it's less than 30% of the faucets have it at a certain rate, they'll clear you for the building. In particular, if, and I'll get to the rates for it for the New York, but if you have a less than 100 parts per million of Legionella in your water, you're considered to have it be like it's a no test. It's non-detectable. It's still in the water. So when you get a result back that's 2, you still have to say, hey, you have Legionella in the water. But it's at a very low rate. That's kind of the big misconception that's going on a little bit that education-wise needs to happen on new buildings. Grows in lukewarm water. They've been linked to domestic water systems, cooling towers, condensers, respiratory care equipment, showers, faucets, ice machines, whirlpool bathtubs, humidifiers, fountains, mist machines. And it thrives in biofilm film, which is found throughout water distribution systems. So especially in really dirty towers and whatnot, it can rapidly grow.
Like those mist machines at Fred Meyer's.
Well, the ones on the side of football fields and
Spraying
stuff,
all
just
over.
spraying Legionella at all these.
Nice.
The problem is, you guys have all had Legionella. The reason why it's called Legionella is that in 1976 at the Legionnaires' Convention, there was a tower that was sucked, their direct air intake came straight from the tower and spread into the building, where all these older Legionnaires members were there, and they all caught Legionnaire's disease. They're immune compromised. People passed away. When you started working for McDonnell Miller and started standing next to cooling towers, you probably got sick for a couple of weeks, maybe just a head cold. But because you're such fine conditioned athletes, you guys just survived it, and you built up the antibodies. So at the Legionnaires' Convention where this broke out, the people that didn't get sick were the ones that were working on it, this filthy tower all the time, because they built up antibodies to it. And it's the same in our case. So what you hear about it most often is, again, in cooling towers, but data shows there's also risk with water from showers. The key prevention of these outbreaks is maintenance of the building plumbing systems. So it's mostly in potable water. So AW2, which is the conference that we go to and we're members of, they revised the regulations to address the maintenance of testing potential point sources in potable water systems. That's important. The reason why that's important is when you go to grab a sample of it and you want to figure out if your system has Legionella in it, if it's a drinking water fountain, group says, well, just run the water for a long period of time and it'll be clear. That's absolutely true. But how often when you go get a drink of water do you let it run for 5 minutes?
Almost every time.
You let the water run for 5 minutes
Not
before you
5
grab
minutes.
a sip of water.
I'm neurotic about it now.
I am too. After this.
Turn it
After I
on,
watched
rinse
a new
my cup
building
out a few times, and
Get
then
started
my
up
water.
when they started up a brand new building downtown.
Yeah.
How long they had to run the water?
Oh, they run it constantly. That's true. It's true on a new
Like,
building.
has
But
flux, is everything in there?
yeah,
already?
but it's not on just new. It's mostly existing systems.
We think about it like
Systems
a
that are TI.
drinking fountain at the airport or something.
Yeah.
I mean, you're right in there.
Why don't they chlorinate the water?
They do chlorinate water for a little bit. That's why you don't necessarily find it when you run the water through it. It's just not enough to kill the bacteria at the point source.
When I was over in the Gulf War, I mean,
Yeah.
our water came out of water barrels.
Yeah.
That were towed behind trucks. And
Yeah.
The chlorine content was so high, you knew it.
Yeah, you can smell it as it opened up.
Yeah.
Most municipalities is 2 parts per million. I know Portland might be different because there's rules and regulations for
Yeah,
everywhere.
they don't even want fluoride in water.
Yeah, and it depends on where you are. Are you end of the line? Are you right where they're treating it? You know, chlorine dissipates pretty quickly. And so they have, and then what a lot of like medical facilities do is they use chlorine dioxide and circulate it through the system. And that's how they kill it. But again, it needs to be returning back to that source. If you were to cut out a shaving right in the middle, slap something in where you're grabbing a sample of it so you're getting the point source water, this is this water I'm getting. It'll probably come out clean. It's at the actual faucets and ice machines and things where water is being stagnant, especially where those U-traps for showers are, that's the most common. And if you grab the sample right away, it's going to look way different than if you grab it 5 minutes later. And on cooling towers, I always like to grab it specifically from circulating sump water. So you can see that on a lot of the controllers, they'll have a little port outlet on it without water circulating. Let it blow out a little bit and then grab a sample from it. Same with if you could open up a side eliminator, grab a sample of the water that's directly circulating in it. Because if you're grabbing particulate off the side of the tower that's growing and then you're shipping it off, it's going to look bad. You want mostly to know if the water that is spraying and spreading if that's becoming a problem. And there are more and more groups that are offering Legionella testing, and we do it too, but all we do is we ship it to a third-party source to validate it for it. It's expensive. It's $120 a sample. And you have to overnight sample it. They need to get it to them within 24 hours. We use one in Michigan. So we're shipping water for $100 each time. Anyway, so owners may require quarterly sampling of the cooling tower's and semi-annual sampling of potable water. I do Amazon and I do CBRE buildings. They all require quarterly testing now because they don't want to get bit by this. They'll also ask to help in developing a WMP plan. That is directly from ASHRA 188. And I think that's on the next slide. And then, of course, we provide sampling services, but there's plenty of places to do it. And as it's becoming so ungodly expensive and becoming so much more common, I expect these labs to be everywhere shortly. There are certain certifications that have to come from OSHA and New York due to separate certifications for labs. So it's important to know that with whatever lab you're using, whether they're OSHA certified or New York Health Lab certified, which they don't always coexist with each other that well. ASHRA 188 standard. Legionellosis risk management for building water systems was published in 2015 and is now code ready for standard language to be put in for water management plans everywhere. These are links. If you do click on them, it'll go directly to those. And so when I send it to you and it gets sent around, hopefully those hot links will actually work. This is a guideline for it, and these are the actual publication for the standard. It's voluntary unless a legal jurisdiction makes it compliance mandatory. So if Portland says you have to have one, that's code ready is, but not everywhere is that way. Although federally, they're making it a standard for most hotels and for most health treatment facilities. And so what's going to happen is that you're going to have a manager of a hotel say, I need to come up with a water management plan. Help me. What a water management plan is, they're going to want a tally of every single source of water, every faucet, every shower, every pool, whirlpool, every spigot. But there isn't actually a level of Legionella testing they're asking for at all. It's just a plan if Legionella were to come up. There is a standard, a legal standard for if you don't do testing and you don't know, and your head's in the sand and someone gets sick, you can just go, I didn't know. And so that wasn't actually written into this code at all. It's just what would your plan be if Legionella broke out? So the New York ones, which are coming up to the New York outbreak, in 2015, 120 infected and 12 people died in New York due to legionellosis. New York City Council immediately adopted the legislation that required the adherence to 188 and started inspecting every cooling tower and implementing a WMP. So most people, building owners have no idea of the water treatment or the water chemistry or that they even have a cooling tower. Everyone immediately started calling in New York. The guys that were from New York looked beleaguered. It has spiked their water treatment business fivefold. But guys that
they're workable hours. They have not that many more clients, but they're working 3 times as many hours because their clients are requiring them to create all these plans.
And not just that, it's just the testing, and everyone now knows exactly what a cooling tower is in New York. New Jersey's adopting this soon. If California adopts it, so will Oregon and Washington. And that's usually how the dominoes drop when it comes to this. It goes New York, New Jersey, sort of East Coast swing, then the West Coast swing. If California does it, this will be a requirement. They went $10 million in sales, or from $1 million to $10 million in sales from just basically doing Legionella testing and treatment. Their biocide rates quadrupled, or how much they had to put into it. Everything got maxed out. And they're guys that can see 60 sites can now see 30. So they're hiring guys like crazy to work out in New York. All sorts of new water treatment companies are moving in to try to fill it up, but this is just one state. So New York maintained that cooling towers were the primary culprit of the outbreaks. They were able to do that basically by finding the bacteria in the tower and linking that to the person. They tested 0 potable water systems. So that's not to say that they didn't get it from the potable water systems, but it's an important thing to kind of note. Where it broke out was kind of an old folks living retirement area. So again, people that are immune compromised, people that can't fight this off quite as easily. New York standards versus OSHA standards, what are non-detectable? New York standards are less than 20, OSHA's less than 100 before they consider action to take place. If you have a rate of over 1,000, you have to report it publicly that you have Legionella in your building. So that's fun. That's the link to the New York guidelines right there. I encourage that if this does come up or it's becoming something you guys are interested more in, look at that link. It tells everything about how to clean it, what the reactions are, if you're getting a rate between 2 and 100 or between 100 and 1,000. What we've done, and we did it for another water treatment group years ago at the Doubletree and SeaTac. Brand X had Legionella, and they go, we don't know how to take care of this. And we had to do was put hydrogen peroxide in the tower. We did it with Chet. Chet Baker had a goatee. He had to shave it off because it was in a confined space. You can't use hydrogen peroxide in a confined space without a breathable mask. So he got fitted for a mask, and I did too. We added it to the system, circulated it for 4 hours, did a turbidity test, which is like the free-flowing crap in the water. It's like how dirty it looks. It is thickness, not like in the TDS sense, but it's kind of, you make everything float. And that's exactly what hydrogen peroxide does. And it will kill anything. If you get on your skin, it burns like, it's not the stuff you use for like a wound. That's 2%? It's 2%, right? It's 5? 25% will burn you, like make your hand white. So, but that's how you take care of it. Pure acetic acid and pyrosand. It's a product that's used a lot for that.
We have a Skype question.
Yeah, go ahead.
One of our viewers wants to know if Legionella is contagious.
No, it's not person to person. It's coming from a specific source. So that one source of tower for those, what was it? I say 120 people that were infected. They were able to link that back to one particular tower. A tower that looked clean. The water looked great. It looked clear. It just had bacteria growing in it. And those droplets from that one tower would have to get to it. So it's like if you are sharing saliva with your wife or whatever, she's not going to necessarily get Legionella. She would have to get the droplets of water from the specific source. So, and that's that happened at the University of Washington too. They linked it to a specific, and that's on the next slide. University of Washington outbreak. They were found at high-risk patients, 2 of which died, all of which were cardiac care patients. And this is between August 24th and September 13th of this year. They attributed it to the water systems at the Cascade Tower. They found it in 2 sinks, 1 ice machine, 3 pieces of operating room equipment. And they basically, there's a huge business now for consultants to go in and test all the medical facilities. One of the guys, actually, the main guys just moved to Seattle, one of the preeminent consultants on it. But they basically hire out their own labs to test all these different systems because they don't want to pay $100, $20 a pot. But they sure as hell charge that. Think of how many sinks are in a medical facility, you know? So, and it's really common. Again, it's on, if you go to that New York standard on the drinking, they have a drinking water specific section to it. If it's less than 30% of fixtures at a certain rate, it's considered, hey, that's okay. So it's the amount that's in it of Legionella. And that's critical to know because I do a CBRE location that is Amazon, and I got a result back of 2. So I went to them. I'm like, what's Mac Miller standard? They're like, well, you should be the one telling us that. What is CBRE standard? And CBRE is like, we don't have a standard. I'm like, well, you technically tested positive, but it's on a non-detectable level. And that information is critical to know because if it's just telling somebody that yes, you tested positive for Legionella, that's great if I'm a water treatment company going to another water treatment company saying your tower tested positive for Legionella. I didn't say 2. I said it tested positive. So that number is critical to know in that piece of information of what actually Legionella and how it can spread and what is dirty in a tower. That CT109 product that we have listed up there only kills 90% of microorganisms that are found in water. So there's another 10% that it doesn't. The one of them that it does kill is Legionella. So a tower can look like crap, but if it has the proper microbicide going in there, you're not going to see a Legionella level on it. And as long as you have the correct dosage rate for that specific tower.
Most of the time when you guys see a dirty tower that has microbicide on it, it's usually like an algae, and that's, again, from the sunlight or some extenuating factor that our biocide can't keep up with because the sunlight's not 24/7, but every day. Biocides only get fed. Typically, that type of biocide, a non-oxidizing biocide, 2 or 3 times a week. So on those other days when you're not feeding the biocide,
Legionella is not found through his vent pipe that's from the sewer system right to the tower. It's found from the make of water going into the system, and then it's replicated. It makes it easier when it's dirty. When it's dirty, it's got nice little pockets to grow. And so when a tower that's why OSHA standards are twice a year. Because they want they want a water treatment company to have a clean tower to work with. Because no matter what water treatment you're adding to it, if it's got a ton of pollution and dirt that's in the bottom of it, it's not going to penetrate that. And you're not going to eliminate. They're giant air washers. They're going to pick up everything out of the sky. Every mold spore or cottonwood bloom that's going to come through is going to feed right in that tower and just. It's a warm, wet environment. It's going to grow like crazy. And Legionella does the same thing. So, and that's why sometimes you see a water treatment program and you're like, wow, this tower looks like crap, even though they're feeding chemical into it. Well, it's only killing, that's why you see 2 different biocides. You'll see like a non-oxidizing and an oxidizing biocide. Oxidizing biocides, it's like chlorine, bromine, pure acetic acid, stuff that's going to off gas. And then the CT109 and different products that are like that, microbicides that are considered non-oxidizing, are EPA-registered pesticides. So,
how can, you go out and clean a cooling tower,
yeah.
And it's gross, you drain it,
yeah.
And you're left with a bunch of sludge. What's a good way to protect yourself? Like, say there is
masks and you seriously, like wearing a mask to kind of deal with it. I mean, it's
like your standard N98 dust mask.
I would say that. I also want to say that you guys have all.
95.
I'm not all. It's not a blanket. This seems like a blanket statement, but it really is. Most of you guys are probably into it because you've already come into contact with it. It's so common. People don't test for it and never have until it happened in New York, and because it's so litigious, it's now becoming a standard. So when 20 times more people die from the flu every year, but you can't stop the flu from face-to-face contagious contact, but you can source where Legionella is coming from litigiously. So when people can sue over it, they're going to want to protect themselves. And this is how New York did it. And
I think if you're asking, say, if we're in a gross tower, I wear a mask.
Yeah.
I wear the paint grade one with the,
Yeah.
or like the 3M one.
I use it when I'm adding pure acetic acid, which I commonly add to systems. It does great. It's awesome. If you put it in a sump that isn't circulating, like that rear trough that I had talked about over here before, you'll see everything float to the surface, and you can scoop it out and throw it away because it's hydrogen peroxide.
If you have, if you have a green layer on the bottom of a tower and you dump in a cup or two of pure sand, you can see it'll just kind of turn brown, and then it'll just start lifting off. You'll just immediately kill the surface layer. And
it turns to water in 20 minutes, and it also is really tough stuff to get on you or inhale. So most of the stuff that you do, that you deal with, that would kill off any of this sort of stuff is not good for you in general. And most of the stuff you're coming in contact with, that kind of soupy mess or whatever, is also not the greatest. It's organic material that is replicating. Your lungs are the same way. So
why don't they regulate like a sewage truck to come up and pump that shit out of there for us? You know?
Yeah.
If they can do it in the porta johns.
Yeah.
You know, you figure they'd be able
Those
to-
porta johns are at the top of the building.
Well, yeah, I know, but we've got some that are on the ground behind.
Yeah,
the building.
you're right.
And well, water management plans too that they come up with. I mean, like part of what they're going to want to know about that is like how close is your tower to your intake to the building, right? Like if your tower is right here and your intake is right there, you know, that's bad. That's poor design. They would want to know that ahead of time. But if it's 5 stories down and in the alleyway or the air intake on the building away from the tower, that's eliminates one of the possibilities of what it could be coming from. Well, maybe then it's not, our Legionella is not coming from the tower, it's coming from potable water.
What kind of flight range are we talking about here with the water?
God,
The
we
reason
went
I
over
asked,
that.
we got a mall here in
Yeah.
Washington Square Mall.
Yeah.
That has a gigantic water tower up on the roof.
Yeah.
With a bunch of heat pumps on the roof,
Yeah.
economizing.
Yeah, and so that's gonna that spray is with wind driftage can be up to a 2 mile radius.
That tower's like
H&M.
20 feet tall.
Yeah, well,
Yeah.
panels are probably about 40 feet
Yeah.
long by 30 tall.
how many ton is the tower?
It's not
Feed the
ours.
whole mall.
I haven't looked at it.
Well, and it might have. They should be testing it. They probably are not testing it, but CBRE of Jones Lang LaSalle, which is why I brought up that other meeting that everyone's in. Jones Lang LaSalle wants it done, I think, annually.
CBRE down here isn't that proactive, at least in my experience.
Well, CBRE nationally
Mhm.
is annually. The ones that are dealing with the Amazon towers are quarterly.
Well, I'm talking
Yeah.
just with their mechanical
Yeah.
programs in general.
I think it's a lot of the guys respond well to the fall management stuff, going up on the roof, sign out, log out. We need to cover ourselves with that. Once it becomes seen as important as that, like you need to do this. You need a contract with a group that does it. Once it gets out, because their response was after ASHRA. Then the New York thing happened in 2015.
Yeah.
And so, this is all the kind of dominoes sort of stuff. And so, again, with the ASHRA plan, you don't actually have to test. But most of them are making it a standard protocol. And then in at least the next couple of years. And I can see it, if you just say, hey, I tested it annually and I came up negative, you have a way to kind of explain away a process that's happening. Even with that, they don't want you treating a system with like pure acetic acid and immediately testing it the day later. They want you to test it 3 days later. They have a whole protocol for it. Mostly because you would want to know if you have Legionella growing in your water, so then you can react to it, and that it's nothing to freak out over. If it's a really low level, it's just an indication that, you need to do something to revise your water treatment plan. So that's kind of what I'm getting at. And I guarantee you that more and more people are going to start asking this question: do we test for Legionella? And the answer is undoubtedly no, because you're going to pay $250 to do it. No, that's fine. I don't really want to do it then. Or it's $150 per sample. I think that price will be driven down as more and more groups decide to start implementing Legionella testing ones. But we use, I'll be full disclosure, use Biosan, where you see those SaniCheck AB tests, their green boxes for, they do it for microbiological testing on towers. Sometimes you'll see them around. SaniCheck is who we use back in Michigan. They're an OSHA certified lab. There's a guy that is across the water from us, but he's not OSHA certified. So, you just want to make sure you're kind of covering yourself there. So, anyway. I put white rust in here just as a general thing. There's a lot of slides on it because I asked Katie in our office to kind of put together. There's a great video that Avapco does on it. But what rice, sometimes you walk into a galvanized cooling tower, you'll see a galvanized cooling tower, and you'll see what looks like scale on the bottom of it all the way around. It's probably not scale. It's called white rust. And it really happens. What Avapco would like for you to do is to land a cooling tower on a roof and let it sit there and acclimate for the next 2 weeks. That never happens. Immediately groups land the tower, get water in them, and start moving immediately.
Acclimate
To the environment. It's seriously, they say acclimate to the environment. So white rust is corrosion is characterized as a localized pitting type corrosion identified by a characteristic of a white, waxy, tuberculous type deposits. Also looks just like scale. If you'll see it right around the edges below the water line, it's just white. It's predominantly newly constructed and installed galvanized steel towers. What happens is when they land that tower and don't call a water treatment company in immediately is that it just cycles up. This cycles up super high because they don't put a bleed on it. They don't put a controller on it. They just fill it with water, put demand on it, and start circulating. Once that level gets above a certain point, once the pH gets up above a certain point, you start getting white rust. And white rust is almost impossible to get rid of. There's a passivation video that's right here. I meant to put the link on it. I still haven't done that. I'll send it to you.
There's no link.
Yeah, I didn't do it, but I'll send it to you. So it'll be in your guys' your class system. But it's what it really wants to get out is you can start treating a system almost immediately once it gets in there. You can call a water treatment company to throw something in, even if they don't have a controller online. You can do something with the water. If anything, put a little bleed on it so that you don't have it cycling up so high. If white rust is hard as a rock on the side, you rub your hand across it and it doesn't flake off at all, it's pretty much done and is not going to go away. It's going to be almost, you have to use an acid to get rid of it. And it's probably not, more detrimental to the system. It's now existing. So there's a couple towers I can think of specifically that have it on it. They said, what is it? I've said it's white rust. It's going to be impossible to get rid of. I'm like, okay, well, now I know that. It is what it is.
Is it just attack the galvanizing?
Yeah, it's basically oxidizing the galvanizing on the outside of it. And it's, so
all you're doing is weakening the metal over time.
Correct. But if it's not like pasty, it's not active, right? If it's hard as a rock, it's now hard as a rock forever. So it's not underneath it coating that way. But if it is pasty, that's an active white rust situation. That isn't scale. And so a lot of what they talk about specifically is what we don't do in the Northwest is that water circulation shuts down during the winter and nothing happens. Now our water, again, is not nearly as hard as other parts of the country, but if there's just layup water like that and that's never circulating, it's going to cycle up or have issues with it. A system that during the winter in particular, we tell groups that at least once a week for an hour, circulate your water. You get your water, you get microbicide in there, you get your inhibitor in there, you circulate around, you move water around, rainwater that's untreated, that's unaccounted for in a system. It's highly recommended that it's done. In the Northwest from November to April, a system may never, ever run. Well, stagnant water is the death knell for water treatment and on systems in general. It's that same pump thing that you're talking about, the pump that never runs, It'll end up looking like crap. So
we usually run into resistance from building management draining towers in the winter because then we'll get that random 65-degree day. And they'll be like, oh, well, I don't want to have to fill my tower and go through the work and start it. So then they just let it sit. So then it's kind of on them to have to run it. I think twice a week minimum would be best. But
yeah, I would like to run it twice a week at loader. Most people can write it into their programming like I call Gary and say, can you put a control setting in for it to run Mondays at 8 a.m. And then if I know a tower is going to be running at 8 a.m., I'll go test it at that one point. Because it's a better representative of what the water actually is. If I'm testing on a tower and it's just filling with rainwater, I'm going to get a different reading than what's the pipe that's inside of the chiller. So, and then this is kind of last topic, I guess, a little bit. I put this in here because it's wave of the future. Now that we're using glasses to film exactly what's going on and uploading into our system, there's water treatment. There's a group called actually Aquanomics right there that is putting a nest technology for water treatment. So it's going to try to figure out the utilage and usage and become the most efficient that it is. So technology, do anyone know what the Internet of Things is? Have you ever heard that term before? This is part of the Internet of Things, so is that camera. It's anything that is connecting to the Internet and sending out. So anything Wi-Fi, anything that is your truck, that has a connection for it. 6.4 billion devices will be connected to the Internet of Things in 2016. It'll grow to nearly 21 billion. So there's an emergence of fast, reliable cellular connectivity for various water treatment equipment. Almost every Advantage Controls, Wallchem, all of them can connect to BMS systems, and they can use cellular readings to give back to any building management group, or send an email, say if my conductivity is high, or if it's super low because we're bleeding out, which is great information to have. I bid the FBI building. They said, I don't want you to have a cellular connection, a BMS connection, or a way to have a Bluetooth at all for any of our systems. The only I want is nuts and bolts as I can get for a controller. The reason why that is a word caution. The Target case study. Hackers broke into Target's retail network using network credentials stolen from Fazio Mechanical, provider of HVAC systems. Target has said the breach exposed approximately 40 million debit and credit card accounts between November 27th and December 15th of 2013. They used Fazio's connection for their HVAC system as a gateway into Target's computers.
So they're monitoring of their HVAC system.
Correct. They found most of them use the lowest level of Java, and it's like the easiest thing to hack in the world, supposedly. And so in the particular Target case, the data connection with Target, the reason why it linked directly, it was an easier connection, is because this is from Fazio itself. The data connection with Target was exclusively for electronic billing, contract submission, and project management, which happens all the time in our industry. And Fazio Mechanical does not perform remote monitoring of control of heating, cooling, and refrigeration systems for Target, but everyone pretty much does now, right? And I'm sure you guys got data guys that can tell what systems are running currently, right?
To a lot of systems.
That if they don't have a block, my brother-in-law works for Disney. After the Sony hack, they said there's 0 gateways. You have to ask for access to everything. But almost nobody does that, So it's just kind of a word of caution. As some of this stuff comes out, there is that threat of what can protect you as well. So having controllers that don't have the latest widgets and gadgets for it may not be the end of the world. Not that I'm advocating necessarily for that. A lot of the stuff is great information. When our controllers at AT&T, they come in, they print a giant sheet that looks like a heartbeat for what your connectivity is. We'll just go like this almost the whole time. If it's crashing like that, you know you got a problem. Or if it's spiking like that, you know that you got a bleed issue. That's great information to have real time. When water treatment guys like us come out, we're only there for the one day that we're testing a system. A lot can happen in 30 days. So it is great information to have on demand. And it's the reason why we like to talk to you guys about all of this information is because you're the other set of eyes. You're the ones that are see if the system is got a bleed you've got an overflow issue. We have a driftage issue, or your bleed is totally plugged. Ascosolenoid has never been cleaned out. There's not a Y strainer in front of it. Most of our problems that happen in water treatment become some sort of minor mechanical issue that can be fixed. So it's important that you guys know kind of like what we do to help out. And then most water treatment groups, not just us, we will have our online reporting that we go in, and we just send an email that's the actual report go into a system. Not as many of the direct hacks through, hopefully, but most groups have test sheets like that. Those are for the building owners to know that they're there. I always write notes to the mechanical groups on them, and most water treatment guys do. So if there's a problem that we see that we'd like for you guys to address but don't have who the contact is on site, it's usually in that logbook. And almost every site has one. So
Yeah, and bless you. But like in Seattle, I mean, I know Dan and Brock and most of the guys, know each other. But even if you don't call them, like they all have a binder or that piece of paper somewhere in the mechanical room. So if you drain a tower and clean it, fill it back up with fresh water, it's pretty common courtesy to write on there, drain tower. And then so when he comes back out,
and my readings are nothing.
yeah, the readings are wiped out.
A call is better. Matt called me today to let me know.
Yeah, we normally do,
Right.
but it's more with the other companies.
Yeah.
That we don't have that relationship with, but you'd write on there, you try to call. Some
And-
people
and-
aren't as responsive as you guys are.
Well, and so our online reporting, so when you do contracts with the water treatment company, they may send it to you or send it to the sales guy, who then doesn't know what to do with it sometimes. Or they'll send it to the building owner. I mean, it'd be really easy to link you guys into whatever that is for what the latest report would be for the person that's doing it. So we send it to McDonald Miller, wherever the direct contact is. And that's still a working thing we're going through. Is like, is that going to the correct person that is then
I don't think
servicing
any of
the
mine
site?
are going to the service tech. Mine are all going to the account rep, whoever that is for.
And that's going in some folder somewhere that never gets looked at.
But it's
Wow.
got, I mean, a lot of that's got history. What is our history looking? And it makes, if our readings are super low, it's giant red with an explanation as to why. So I mean, I guess that's kind of more or less. It's a really codependent relationship. We really rely a lot on working with mechanical contractors. We like to say we're a water treatment company, but really we're a service business, and we are good at coming up with solutions for problems. And that's the most common part of our job, I think, because everyone sells the same water treatment chemicals. It's really how good are you with a customer and how responsive are you? And that reflects on both companies. So if it looks like Mac's never doing anything because they're not responding to us or vice versa, they're like, well, you guys don't know what the hell you're doing. So I think it's important that you guys, I don't know, that's my 30-second blurb as to why education is important. So anyway, there you go. So, yep. Any questions on anything at all?
Where's the beer?
I know.
Oh, that was the SKF class, you missed that one.
Awesome. That's why everyone's there.
Yeah.
We should supply it. We do a lot of
They're all
breweries.
golf boys too.
We do a lot of breweries.
How come we can't align the shaft yet, gang?
We appreciate your guys' attention there.
Yeah,
Be
there's
kind
good
of boring.
information.
If you guys want any, if you give any of these bottles, is there someone that comes up and down from Portland to Seattle? On a regular basis?
You know, there's emails that go out, hey, anybody going to Portland, or hey, anybody going to Seattle?
If you want to get
I got
this
a
to
package.
Detroit Avenue, any of these, all these 12 bottles or so there.
Seth will be going back up there.
Yeah, I know. Well, anybody, really, just throw them in their truck and give them to.
Just leave them the whole bucket.
I had a bunch of those. I just threw them out. That's funny.
Ours?
Not
Son of a
those
dust. I'm sorry, Travis pointed this out. There's such dinky little heads on the
They're hard to
so
fill.
they're hard to fill. But the giant wide mouth ones that were before, they'd always think they would freeze and leak in guys' trucks, and I would get nothing. I'd get like that much left. And they're like, what is in this?
If you don't have a funnel in your truck, what the hell good are you?
Well, a funnel or stick it directly underneath. When in doubt, a water bottle, a true water bottle, not Gatorade, not Powerade, because that affects readings. Just a great water bottle that you can dump out and refill also works. But anyway, you guys go. There's more bottles there, and they tend not to break.
Yeah, you could always send those with the driver. It goes between the two. There's always somebody going between.
Yeah.
Yeah. Get
Isn't
them
Dave
tested.
down here all the time?
Huh?
Isn't Dave down here all the time?
Dave,
Dave?
I don't think so.
Is he not?
Bruce probably comes down the vehicle guy.
That's right. I was
But-
going to clean off that.
Steve Merkel's down here. I'm down here. There's a truck that goes at least once a week.
Dave Tag, right? Dave Tag's down here a lot? Yeah.
He used to be.
Yeah.
Thanks, Steve.
I don't know. I honestly
Steve
don't
took
keep
over.
track of Dave tags, so I don't know. What
Let's keep her.
I really don't. I'm kind of talking on my ass.
Yeah.
Cool.
Thanks, gentlemen.
Thank you.
And please, I mean, I have no problem. Call us for anything. If they're not our sites, I'll let you know. be happy to help you guys out.
Yeah.
Tell us how to jump, so.
Hey, Brock comes down every month, no matter what, we have a site right on Columbia Avenue. And then Nathan often comes down from our group as
I'll go
well.
grab the hat. You gotta see it in
And he goes
person.
all the way to Salem.
Yeah,
So,
really understand
yeah.
it.
Awesome.
Yeah.
Thank you.
Sure.
Keep my switcher warm.
Thanks, Seth.
I'm gonna watch this. No, that's what
Thanks for coming down. I was trying to, warn them. So here we go.
Did I dumb it down a little bit more than Ed? Hopefully.
Yeah. Yeah, man, that was great.
Did you video? I didn't see the little link to the video.
Yeah.
Was it videoing the whole time?
Yeah, we actually had a participant, Evan.
Huh.
I'm trying to get him to try to unmute him.
There's gonna be the part where everyone
Evan!
went out to get pizza and Dan and I were in here bullshitting.
Oh yeah.
What?
Evan,
Yes, Seth.
hey, you had yourself muted.
Yeah.
I was trying to unmute you. How did that
Oh.
sound? Could you hear?
Yeah, it sounded great.
Really?
Any
Yeah.
other questions?
You can't see anything on the whiteboard, but other than that,
Oh, from this one? Oh, that's too bad.
yeah.
Have a good night.
See ya.
That's what, tomorrow at 8 for lunch?
Yeah.
Thanks, Rob.
Yeah, thank you.
Here you go, Evan. Oh, the writing's backwards.
Yes, it is.
That's weird.
Oh, no, it's not.
It
not
is
on my
mine.
screen. No, we're good. Okay, that's enough.
Oh, I'm stuffed, man. I had a lot. I had
Good,
4
Rob.
pieces.
Well, hey, thanks for being the tester, Evan.
Yeah, no problem. I'll talk to you tomorrow.
Do you want to leave these?
I like the screenshot too.
I just wanted to show you what it looks like.